subject that I've been asked to talk about today is nature-based solutions in urban areas to support climate change adaptation. So my first slide is intended to illustrate what a nature-based solution is. This diagram you will be able to access on the PowerPoint, which I think is going to appear on UNIBA's website at some time. But this is the result of a piece. It was written by a group of researchers, and I find this a very helpful diagram. The key things to bear in mind is that a nature-based solution is essentially derived from an ecosystem approach, that it's about addressing societal challenges, the challenges that we all face, and the two key outcomes that we're looking for are benefits for nature, biodiversity benefits, and benefits for human well-being. And well-being is more than just our health. It's how we feel inside. It's about many unspoken values that we all have, whether they be spiritual values or cultural values, and how we live our lives as contributing members to society. Before I go on, I would just like to say a few words about Clearinghouse, because as my long-standing friend and colleague Giovanni Senesi has said, Clearinghouse is a collaboration between Europe and China. And it's the very first cooperation on urban forest nature-based solutions between the two continents. And to bring some focus, we have a number of case study cities. And how we're approaching that is twinning. So we have twinned Brussels, the capital city of Europe, the cities of Leipzig, Halle, which is in eastern part of Germany, the former German Democratic Republic before the fall of... Many of your mobile phones have probably been made there. The historical city of Krakow, the old capital of Poland with Hangzhou. Gelsenkirchen, which is an industrial area of the Ruhrgebiet in western Germany with Dubai. And finally, the glorious city of Barcelona, everybody's favourite, I guess, was Yemen. So these are the twinning projects, and we're working very closely with the Chinese Institute of Forestry, based in Beijing, and the European Forest Institute, which, although it's based in Finland, we're operating the project from its office in Germany, in the city of Bonn. So, we have a problem. It was suggested earlier on that I should put up a picture of Apollo 13. For those of us of a certain age, probably might remember that. We have a problem, Houston. But we have a problem. And that problem has been described very starkly recently as a climate emergency. I'm sure you will have all witnessed the terrific forest fires that have been burning out of control in Australia over the Christmas, early New Year period, which is one example of how bad it can get. And you don't need to look into deep science books to see what the problem is. Essentially, if we ask NASA and their climate research, we get this table, which tells an important story, that the warming that we have seen on the planet over the last decade is too large to be caused simply by solar activity. And we know why that is the case. So here we see a graph of solar activity. I think most people know the sun's activity goes through 11-year cycles. And we see our global temperature, and you don't need to be a rocket scientist, sorry to come back to NASA, to realise that those two tables, or two graphs rather, are not in correlation. If we look at what we call grey literature, that is journals, popular science journals like New Scientist or Scientific American, or some of the high impact journals like Nature and Science, etc., we soon discover that we have broken every climate record in modern history. The polar regions, especially the North Polar region, have been very badly affected. Not this winter, but the winter before, there was one day when it was warmer in Greenland than it was in London. We have heat waves. I remember here in Bari about 2 or 3 years ago there was an enormous heat wave. I think it was called the Twig or something or the other. But it was very, very hot, and those heat waves are happening across the globe. We're getting monthly temperatures being broken, and we have this phenomenon called climate deniers. And indeed there are those climate deniers, most of which are based in Canada, it seems, that believe there is no climate emergency. And these well-funded scientists, who are, in my opinion, misusing the scientific method to reach extraordinary conclusions, believe that this is all a propaganda stunt and that we don't really have a problem that's anything other than natural. But there are people who are very well spoken. If you follow television nature programs, you may know this man. This is an Englishman, Sir David Attenborough, famous for many years for his nature programs, and he says that the Holocene, the geological era that we have been living through, has ended. The Garden of Eden, biblical reference, is no more. We have changed the world so much that scientists say that we're now in a new geological age. And we refer to that as the Anthropocene, the age of humans. In other words, we have replaced natural processes as the predeterminant of what happens on our planet. Okay, let's do some basic climate science. On the one hand, you've got the scientists looking at the data, looking at the graphs, and you've got politicians, I'll mention no names, but you'll find them in Washington and London, looking at voting intention surveys, opinion polls, and to find out what the public want and offer the public what they want rather than following the science. I think the most important thing before we turn to nature-based solutions is to recognise that we're standing on the shoulders of climate giants. That there is a long history of the basis of the scientific or sound science when it comes to climate. Starting with the experimental work of John Tyndall in the 19th century, looking at those that have done calculations and observations through measurements, and then in more recent times, prediction. So this science that we are embedding our work in urban forestry on when we're talking about climate change adaptation is built on sound and long foundations. The first concept that we really need to grapple with is called the Keeling curve. Keeling curve is a measure of how much carbon there is in the atmosphere, measured in one particular place called the Mauna Loa in Hawaii. This is a very high mountain. If it was on the Earth's surface rather than at the deep of the ocean, it would be 5,000 meters taller than Mount Everest. It is actually the tallest mountain if you think about it. And we have been able to measure atmospheric carbon dioxide since the 1960s, and what we see is this graph, and scientists use the parts per million, as it's called, as that measure of carbon. concentration. And you can see it's raised from 320, or just less than 320 parts per million atmospheric carbon in 1960 to 2010, around about 395 ppm or thereabouts, and it is widely expected that the 400 parts per million carbon will be passed very soon. I'd like you to bear that figure in mind. Now, what we know is that that global concentration of carbon dioxide is really linked to development, to human development. It's been rising slowly from 1870 through to the 1930s, and the so-called post-war boom, which took place after the Second World War, 1945, has resulted in getting steeper and steeper, and the industrialization and the end of the Cultural Revolution in China marks the most extraordinary period of rapid growth. And China has gone, as a made from being a third world to a first world country in a very short period of time. So what does this add up to? Well, if you look at the figures from the mid-19th century, 1850 to the modern period, you will notice that we see a steep rise in temperatures. Steep rise in temperature doesn't necessarily, of course, imply that we are necessarily looking just at warmer climate, because a warmer air holds more moisture, and more moisture in the air means more rain. So we're finding the climate across the globe is changing. Some places are getting warm and dry, others are getting warm and wet, and it even, ironically, in some places leads to colder weather. And indeed, we can go on and see the changes. We see not only global average temperature raising by some degrees, we see global sea level rising, and importantly, we see snow cover decreasing. That still didn't mean that it didn't snow over the Apennine yesterday when we were coming back from Rome, but be that as it may, snow cover is declining. What is very powerful, and to me really hits the climate deniers on the head, is that regardless of which of the main agencies you look at, their figures are so close together. It is deeply impressive. Just look at this. I can hardly think of anything else I've encountered as 40 years working in this field that so well matches. You've got the NASA Goddard Space Institute, the Hadley Centre in the United Kingdom, so-called Met Office. You've got NOAA, which is another North American agency, the Atmospheric Administration, and you've got the Japanese Meteorological Agency, and they all show a very close map, and the trend, once again, is very obvious. And do we get that sinking feeling? Well, if you live in a coastal city in Italy, you might have a few things to worry about. I wonder, oh, we're in a coastal city in Italy. Yes, sea level is rising, and the rises might seem relatively modest, but when you have a stormy night, like last night, you get a thing called storm surge. Storm surge can lead to significant flooding and, in places, loss of life. So this needs to be taken quite seriously. And a 1.2 metre rise between 1990 and 2100, which is definitely beyond my lifespan, and perhaps most of us in this room, can be expected. So the melting of fresh water in the Arctic and in the Antarctic is raising the sea level. And we can see the impacts of that. This is a picture from the United Kingdom. This is DEFRA, the Department for Rural Affairs. They have access to satellites. And this shows how the extent of sea ice in the Arctic is retreating. You see the black outer line, where sea level ice used to be, the yellow inner line more recently, and you can see, of course, in white exactly what's happening. At the moment, there seems every reason to believe that by 2050 there will be no sea ice left at all in the Arctic. And the consequences of that in the global climate system is enormous. We also get ocean acidification as a consequence of all of these changes, because of course you mix water with carbon dioxide, you get a weak acid. And that acid, of course, reduces the pH in the ocean. The oceans, of course, have limestone in them, the shells of sea creatures, and of course they're made of calcium. You don't need to be a particularly advanced chemist to know what you get if you put acid on calcium shells, which are calcium oxide. You get more CO2, amazingly. And indeed, people are starting to get worried about what's called the tipping point, a point at which we lose control of the system. Now, scientists by nature are very cautious people, and the scientific method suggests, however, that even in the low scenario world, that we're going to see temperatures rise. And in fact, to restrict ourselves to the Paris Agreement, which is a 2-degree rise in temperature by the end of the century, is almost impossible. It's almost impossible. So mitigation alone, this is why the core of what I'm here to talk about today, is not going to solve the problem. We have to think about how we live with climate change. It's quite scary, isn't it? If you looked at the high emissions, nearly 6 degrees that's a lot of temperature increase. So the second part of my presentation, I've done the science with you, you know what the problem is now. Do we adapt or do we mitigate? Or is indeed, are they the right questions? Well, this table is around stabilising emissions and avoiding that temperature rise. And what it says is for there to be a 50-50 chance of staying below the 2 degrees centigrade relative to pre-industrial temperatures, we have to stabilise the concentration of atmospheric CO2 at 450 parts per million. And that means that we've got to cut emissions by at least 50% of the level in 1990, 30 years ago, and it's been growing ever since, by 2050. Well, I don't know about you, but given the political climate in the world at the moment, I have little faith that that is achievable. Now, I rather like this quote. Mitigation, climate mitigation, is about avoiding the unmanageable. But climate adaptation is about managing the unavoidable. And the balance in my working life has switched from a discourse, a discussion about mitigation towards the discussion about adaptation, managing the unavoidable. Now, to meet that mitigation challenge, it requires fundamental changes to the way in which energy is produced and used. And as I've already indicated, there are skeptics out there who believe, as Bob Watson, the former United Kingdom head of the International Committee on Climate Change and a former chief scientist in the UK, said, is probably wishful thinking. We are making attempts. The most notable, of course, is the switch from fossil fuel use in cars towards electric, and finding ways to produce electric in a more environmentally sustainable way, although it's doubtful whether nuclear energy is really that environmentally sustainable. If they can solve the waste problem, perhaps will be. And there are things that we can do to mitigate. We can reduce our greenhouse gases at source, doing things like, for instance, closing down coal-fired power stations. And we can enhance the sinks, and we'll be coming back to this. There are two particular ones of importance and of interest to me. One is trees, and the other is soils. And we can manage supply and demand. We can try and capture carbon. There's lots of engineers at the moment thinking about carbon capture technologies. We can switch to renewable energy, of which wind, wave power and sun are the most popular. I would like to just mention something in respect of the sun. I was listening to a broadcast on CNN, one of the American news channels, and they were interviewing somebody from Greenpeace. And very clever, this person says, "Oh, I believe in nuclear energy." And you could see the person taken aback that somebody from Greenpeace would say they believe in nuclear energy. And then he said, as long as it's 90 million miles away, which I thought was quite smart, because that's how far the sun is from the Earth. There's energy efficiency measures. Just yesterday I was talking with Raffaella and Giovanni about how much more economical cars are these days compared to old ones. I know my car, for instance, does more than twice the miles that the first that I ever had years ago. So energy efficiency is important, and then there's the whole issue of new technologies. There are options. But, coming back to this core point, adaptation will be crucial in reducing vulnerability to climate change, and is the only way to cope with the impacts that are inevitable over the next decades. This is a quote from the Stern Review, 2006, it's some years ago now. And this is the Thames Barrage, which is an engineering, it's not a nature-based solution, but it is a solution of sorts. I was told that when the barrage was first built, that it was operated on average 2 or 3 times a year. It's now being operated 20 to 30 times a year. So they're now talking of building a second barrage that's bigger than the one they've already got. Okay, this is leading me towards nature-based solutions. So what do we have as types of adaptation? Well, there are really 3 categories, and they're shown in the bolder type. What's called anticipatory adaptation, or perhaps to use that Americanism, proactive adaptation. Then we have autonomous adaptation, or spontaneous adaptation. And finally, we have planned adaptation. We also have these 2 terms, and these are really important. We have maladaptation. Any change in natural or human systems which actually make problems worse, even although you might be trying to make them better. And this is something that very often the case, I fear, with grey infrastructure solutions. So an adaptation that does not reduce vulnerability but actually increases it. And indeed, the amount of effort that goes in is disproportionate to the results. Dare I say it, there's an Italian example. Venice. Venice spent much of December underwater, yet the Italian government has spent an utter fortune pumping out water which it's now having to pump back in, because they didn't work out that actually if you pump the water out, the city will sink. So that is a classic example of maladaptation. But what we're really interested in is this one, no regret adaptation. Activities that would provide immediate economic and environmental benefits and continue to be worthwhile regardless of the future climate. People in economics call this a win-win situation. Also under no regret adaptation are activities that would be justified under all plausible scenarios, not just the 6-degree one, or even the 2-degree one, maybe the one for 0.00001 degree, including without climate change altogether. So it's this win-win situation that in nature-based solutions we're really exploring. Things that could be justified even although they will have an impact, we believe. There's no regret adaptations, but at the same time would be good in any case for other reasons. Okay, a few words about what a nature-based solution is, and I return to this diagram as a reminder. It's an ecosystem approach, so we're thinking about nature. But we're thinking about nature as a whole. We're not just talking about polar bears or pandas or an olive tree. We're talking about the whole system of nature. It's that works together. It's by harnessing the ecosystem approach, sometimes called ecosystem services, applying them to a range of issues like restoration, infrastructures, management, protection, all of the challenges that we face as a society, directing them towards our needs as a society, which may be local. It could be that in one place, like Venice, they have a problem with flooding and that's their big issue. In another city, it might be to do with the need to revive the economy by buying in big time to the European Green Deal, which is much talked about at the moment. It might in another area, like the sub-Saharan region, be to halt the spread of the Sahara Desert. Or it may be in Lampedusa, for instance, where all of these refugees are arriving from Africa. Not all of them are coming here as a result of war. Many of them are coming here as climate refugees because they can no longer live or farm their lands in sub-Saharan Africa, in Mali, in Eritrea, and parts of Ethiopia. So these societal challenges are not just global, they are local. And as I stated earlier, we're clear what the outcomes we're looking for. It's about our well-being as humans and the benefits to nature. Sometimes some of you may be aware of the word agency. It's a tricky word even in English, perhaps in Italian it's even more tricky. But agency can mean something like a travel agency, a place you go to get your tickets. But agency also means about rights and responsibilities. We are, as humans, we have responsibilities for the planet. Some put that down to Enlightenment thinking, other people go back to biblical thinking. But it's often said that actually we're not the only ones with agency. We're not the only ones with right to life. Plants and animals do as well. And we have dominion over them because of our ability in the Anthropocene to make changes that can affect everything. So our responsibilities are not only to ourselves, but to all of nature. Now, the organisation perhaps most familiar with the term nature-based solutions is this one. This is the logo of the International Union for the Conservation of Nature. It's an affiliate organisation of the United Nations, and as it happens, they have their big conference every 5 years. This year it happens to be this year in Marseille, in France. I understand that somewhere around 40,000 people are planning to attend. So when I heard that, I thought, Marseille, no way, I'm not going. But their definition are that a nature-based solution is an action which protects, sustainably manages or restores natural or modified ecosystems, that address societal challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. So that's your homework, to go and remember that quote. So, I was asked by some of my students at Newcastle University what the ideal nature-based solution looks like. And I created that slide to give some simplicity. It should first of all be no regret, and it should fit into at least one of these categories, the more the better. It should be anticipatory, we should be able to see it coming and do something about it. It should be proactive, meaning that we actually get on the case and we do something about it, and it should be planned, because good planning is the essence of a good output. Okay, let's come on to the nature-based solutions themselves that meet these three criteria, and I want to speak to 5 of them. But to do so, and I don't intend to go through these slides because they are quite comprehensive, and I hope that you will have access to these on the website, and I'm sure we can make those available. This is from a paper by researchers dated from 2007 and by Swart and Rees 2007 around mitigation and adaptation. But it boils down to these. These are the 5 categories that I wanted to say a few words about before I come to a conclusion. The first one to mention, and there's a little photograph to illustrate each one, is called sustainable urban drainage. There is a problem in many ways that we have created. We've created major cities. In Asia at the moment there are cities of 10, 20 million. In fact, I think Shanghai has exceeded 30 million, or is very close to doing so. Is officially the world's most populous city at the moment. It used to be Tokyo, but I think it's Shanghai. And wherever we create urbanization, we have a problem of water. And what we do with that water. Now, historically, the solution has been to put it into pipes, pipe it out of the city into the sea or into some sort of water body. The second one I wanted to highlight is the term renaturing. Renaturing of cities involves bringing vegetation back into cities again, and doing so on a large scale. A problem, and I work with a lot of planners, a problem is that they very often think small rather than think big. Wouldn't it be wonderful if we could do a survey of Bari, and I don't know how much open space there is in the city, green space, Raphael, any idea? 10% maybe? Yeah. Something like that. And say, by the end of the century, half the city was green. Now, that's not as extraordinary as it sounds, because London, for instance, is 45% green space. So it can be done, and London is an amazing city. So every city should aspire for a significant renaturing. The next area is urban forestry, and that's what I'm investigating with colleagues like Raffaella and Giovanni and Yole, where we're looking at the power of trees and other forms of woody vegetation as a nature-based solutions. Some examples, I've already talked about cooling. In fact, I think the very first project we worked upon was around thermal comfort. But cooling is one of those benefits, but other benefits include, for instance, homes to nature. Much talk at the moment about micro-habitat management to get birds and insects back into urban areas. Another possibility, of course, is that trees are often the venue for recreation and also for education as well. Then we have green infrastructures. I'm using the plural here to make it clear that I'm talking about elements like green roofs, green walls, and of course what has become famous here in Italy is the Bosco Verticale in Milan, and there are now other vertical forest buildings appearing. This is one example of creative thinking. And then finally, the restoration of ecosystems. The European Union has a policy, it's a long-standing one called Natura 2000, which is all about the preservation and maintenance of ecosystems. And for the most part, we've allowed, across the continent, those ecosystems to deteriorate. One of the most important ones are these things called upland mosses. They exist all over Europe. They're certainly in northern Italy, above a certain altitude. They're like sponges. The water falls on them and is held there. The soil is very, very important as a carbon sink. And very often we've allowed these areas to dry out, sometimes unintentionally, but often planned. And we need to stop that process. Okay, I've spoken then about various things. I've introduced to you today the challenge. I've talked a little bit about mitigation and adaptation, and then I've said a few words about nature-based solutions, urban forestry, water management, renaturing, and I'd be delighted if there are any questions, if you have time, to explain a little more about those. But if you want to contact me, I think, well, all you need to do is ask Yole, who has my contact information. I hope I haven't talked for too long.
No, it was fine.
Okay.